right, playoffs time, 2024 AMC 10A, problem 17. Two teams are in a best 2 out of 3 playoff. The teams will play at most 3 games, and the winner of the playoff is the first team to win 2 games. So it's best 2 out of 3, they call that. If one team wins the first 2, it's over. You don't play the third. Only play the third if it's tied. If you're familiar with sports, this kind of happens quite a bit. The first game is played on Team A's home field, and the remaining games are played on Team B's home field. Team A has a 2/3 chance of winning at home, and its probability of winning when playing away from home is P, an unknown value, a variable. Outcomes of the games are independent. The probability that Team A wins the playoff is 1/2. Oh, and the outcomes of the game's independent. Like, in other words, emotions don't affect, right? So if you lose one game, you're not like more likely or less likely to lose or win the next. Not like, say, if your name was Draymond and you tried to kick a player named LeBron on Game 6 in the home court of NBA Finals, and then you get suspended for Game 7 as a result, those types of things don't happen because these are fictitious players with no emotions, unlike Draymond, who has just no emotional control. Okay, so anyhow, the probability that Team A wins the playoff is 1/2. Then, not that, just fictitious total story. Then P can be written in the form 1/2 of this quantity. At this point, don't read any farther. It's just a standard ending of some kind. There could be a couple variations, but it doesn't really matter. This is nasty looking. We don't really want to process it right now. It's not where you're at in the problem. Instead, the goal is to figure out what P is. So the ways that Team A could win, they could win the first 2 games, they could win the first and the third game, or they could win the second and third games with B winning the first. These are like individual events, A winning game 1, A winning game 2. Now, since they're independent events, we can multiply their probabilities. So we can say that the chance that A wins game 1 is 2/3, and the chance that A wins game 2 is P, plus the chance that A wins game 1 is 2/3, and the probabilities of the 2 events, or all events, have to add up to 1. 1 being a 100% chance that something happens. So if the chance that A wins is P, the chance that B wins has to be 1 minus P, and the A here is P. Finally, if B wins game 1, which will be a 1/3 chance, again, just 1 minus 2/3, then the chance that A wins the next 2 is P squared. So where do we want to start with this? I don't know. You could factor out 1/3 P right now. Would you? I guess you could do that. Let's just start. It's almost like the longer you stare at it, figuring out what's best, you might just want to distribute it. So this is going to equal 1/2 in the end. I'm going to factor out 1/3 P. So you're going to get 2 plus 2 minus 2P. I'm going to distribute this 2 to here and here. That P and the 1/3 got factored out. Okay, be careful when you do this you don't leave something behind or just add something extra or miss something, because then you'll have major problems. Plus, over here, we're going to have a P value left as well. And this will equal 1/2. Okay, so at this point, maybe I shouldn't have factored out the P. It didn't really do any good. I just noticed that I could, but whatever, it happens. Multiply by 6 to get rid of these fractions. So I'm going to get 2P, and I'm going to go ahead and distribute that now. Over here, you're going to get 3. Okay? So now 2P distributed. Should I combine like terms in there first? Okay, I guess we will. 2P times 2 plus 2 is 4 minus, I'm going to make sure to make any mistakes in there. 4 minus P. Okay, so then now what? We can distribute this 2P. We're going to get 8P minus 2P squared. Maybe it was a good idea. Maybe it made it easier to cancel things out in there or something along those lines. So 8P minus 2P squared, and there's the 2P, yeah, because 2P times negative P. Yep, we're good. Just want to make sure. And that's going to be equal to 3. So at this point, I'm going to move the things to this side because, yeah, so 2P squared minus 8P plus 3 equals 0. Ever since I was young, negatives hate my guts. So as a result, rather than move negative 3 over here to be negative and then run a negative through, I find I make more errors when I do that. So I just move things to the side where the leading coefficient will be positive. And I might have to do a little bit of extra work, but I make less mistakes. I accept. Okay, so now what? Are you going to factor it? What do you think? Probably not, because that doesn't look like something that got factored. So let's do negative b, which is 8 plus or minus the square root of b squared, which is going to be 64, minus 4 times 2 times 3, which is 24, all over 2a, which is 4. So now what about this plus or minus? How are we going to do that? We'll figure that out in a minute. Let's keep going. You're going to get 8 plus or minus 2 rad 10 over 4. And that's going to become, I guess 2 can cancel out. So you're going to get 4 plus or minus rad 10 over 2. Okay, so now let's think about it. Which one is it with the plus or minus? Why do we get plus or minus? Because they just have a minus. We could probably infer it's just minus. But we should be asking the question, why not the plus? Well, what's 4 plus root 10? Well, root 10 is a little bit more than 3, so let's say 7. Total, 4 plus 3, 7, approximate over 2. Is the chance that P wins 350%? No, which is why it must be that the plus goes away, and that's why you only have the minus 4 minus root 10 over 2. And so let's see, is that right? 4 over 2, 8 over 4, yeah, okay, we're good there. So now what? We need to add up these numbers. The half gets pulled out, so you have 1/2 times 4 minus root 10, and it wants to know the sum of those two numbers. Let's double check. M and n are positive integers. What is m plus n? So 4 plus 10, the answer will be 14. And that is the end of this one. See you in the next one.